Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this quadratic word problem. So as per the word problem, Jane walks 15 meter diagonally across a rectangular field. She then returns to her starting position along the outside of the field, and the total distance she walks is 36 meters. And we have to find the dimensions of the field. So the first step here is to draw a diagram for this problem. So in this case, the shape is a rectangle. So we'll draw a rectangle. Now, as per the problem, Jane walks 15 meter diagonally across the field. That means the length of the diagonal is 15 meters. So that's the first step. Now we can label the corners of this rectangle, so it will become easy to reference the sides and diagonals. Now we are given that she then returns to her starting position along the outside of the field. So she starts at point A, goes to point C, and then she comes back to point A by traveling from C to D and D to A, because it says that she then returns to her starting position along the outside of the field. So that means she goes from C to D and then D to A. And then the total distance she walks is 36 meters. That means the distance from A to C and C to D and then D to A together is 36 meters. Now we have to find the dimensions of the field. So that's the length and the width, because a rectangle is defined by its length and width. So we'll start with let statements to define the variables for the length and width of this rectangle. So our let statements can be: let x represent the length of the field, and the next statement can be let y represent the width of the field. So we can show that in the diagram. So this will be x and this will be y. As we know that in a rectangle, the corner angles are right angles. That means the triangle ACD is a right angle triangle. And this 15-meter side represents the hypotenuse of this right angle triangle. So our first step is to use Pythagorean equation to write an equation for this problem. The Pythagorean theorem equation is a square plus b square equals c square. And in this equation, c represents the hypotenuse and a and b are the other two side lengths in the right angle triangle. And in this case, it can be x and y. So x square plus y square equals 15 square. And we know that 15 square is equal to 225. So that's our first equation with x and y. Now since we are using two variables, we need two equations to find the value of x and y, and we are given that the total distance she walks is 36 meters. So our second equation will be then 15 plus x plus y equals 36. And now we can simplify this equation by subtracting 15 from both sides, because 36 and 15 are like terms, so the 15s on the left side cancel each other out. So we get x plus y equals 21. So this is the second equation we get for x and y, and now we have to solve this equation and the other equation to find the values of x and y. So here we can use substitution method. So first we can isolate x from this equation. So we can subtract y from both sides. So the y's on the left side cancel each other out. So we get x equals 21 minus y. Now we can do the substitution for x in the equation we got from the Pythagorean theorem. So we get 21 minus y squared plus y squared equals 225. Now we have only y in this equation, so we can solve for y. So the first step is to distribute the square on the first parentheses, so we can write it out twice. So 21 minus y times 21 minus y plus y squared equals 225. Now we can distribute the terms in the parentheses using the FOIL method. So 21 times 21, so we get 441 minus, so 21 times negative y is negative 21y, and negative y times 21 is negative 21y, and then negative y times negative y is positive y squared plus y squared equals 225. Now we can combine like terms. So y squared and y squared are like terms. We get 2y squared. And then we can combine negative 21 and negative 21y. We get negative 42y. And then plus 441 equals 225. Now 441 and 225 are like terms. So we can subtract 225 from both sides. So the 225s on the right side cancel each other out, and on the left side, so we get 2y squared minus 42y, then plus 216 equals 0. Now this is a quadratic equation. So we have to solve this quadratic equation to find the value of y. So the first step is to simplify this quadratic equation. So we can divide each term by 2 to reduce the numbers in this equation. So we get y squared minus 21y plus 108 equals 0. So by doing this operation, we have converted this complex trinomial into a simple trinomial. So it will be easy to factor this equation and solve it. So here we have to use the sum and the product rule to factor this equation. So we have to find two numbers whose sum is negative 21 and product is 108. So the two numbers that come to my mind are negative 12 and negative 9. We can also use quadratic formula. If you are not able to factor this equation, you will get the same answer. So the factor form will be y minus 12 times y minus 9 equals 0. So we get two cases. So y minus 12 equals 0, and then y minus 9 equals 0. So from the first case, so we add 12 to both sides because we want to isolate y. So we get y equals 12. And then for the other one, we add 9 to both sides. So the 9's on the left side cancel each other out. We get y equals 9. Now the next step is to find the length. So we have to find the x value for both of these y values. So we isolated x as 21 minus y. So we can use that equation. So x equals 21 minus 12, so which is equal to 9. And then for the other one, we can do x equals 21 minus 9, which is equal to 12. So in both cases, we got the same pair, 9 and 12. So that means the possible dimensions of this field are 9 meters by 9 meters. So we can write a closing statement to summarize the answer for this word problem. So the dimensions of the field are 9 meter by 12 meter. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.